Hello students, very good morning to all of you. In today's class, we are going to focus the remaining concepts in the chemical kinetics. Have you got it? So now the remaining concept in the chemical kinetics is types of order of reactions. You all know very well, we have discussed clearly about order of the reaction. What is meant by order of reaction? You know very well, it is the sum of the powers of the concentration terms in the rate equation, which is experimentally determined. Rate equation is experimentally determined. Okay, so order may be 0, negative, fraction, 1, 2, 3. You know very well all these things. So now today one of the order. So according to our syllabus, they gave only 0 order and first order reactions. 0 order reaction and first order reactions are given in according to our syllabus. So today, complete information about 0 order reaction we are going to focus. Have you got it? So all of you put side heading 0 order reaction. First we need to have a complete idea about 0 order reaction. So what is the speciality of 0 order reaction? If you see, what is the speciality of 0 order reaction? Here it's a special type when compared to all remaining first order, second order, third order, all those things, it's a different. What is the different? Here you see. The rate of the reaction, you can take it, the reaction in which rate of reaction independent. Rate of reaction is independent, not dependent. You have to remember. Independent. Okay? Independent. On concentration of reactants. Such type of reactions we can call it as like a 0 order reaction. You see what a different. Okay, so 0 order reaction means the reaction in which rate of reaction is independent on the concentration of reactants which are present in the reaction. Okay, so independent, but till now we have discussed rate of reaction is directly proportional to concentration terms of reactants. But here not like that. This is quietly different when compared to all others. So that's why we can say this special type of reactions. Okay sir, as you said, nothing but rate is not depending on the concentration terms of reactants. Then it is depending on what? Here you have to see. So it's depending on different category types of reactions, different conditions. I will give you clearly. You see examples. What is 0 order reaction? After that, examples you can take. Example number 1. First of all, you know very well, enzyme catalyzed reactions you can take. So all enzyme catalyzed reactions are coming under what? 0 order reaction. Have you got it? So next, second example for the 0 order reaction. Here you see that photochemical reactions. You can take photochemical reactions. Next, third one you take. What is the third one? If you take, that is reactions in which taking place, or simply the reactions which takes place, you can take like reactions which takes place in the presence of metal surface metal surface at high pressure, So total, these three types of category, these three types of reactions are coming under zero order reaction. So first of all, again I want to tell you here, everyone should focus. Zero order reaction means these are special types of reactions, not a normal type of reaction, special type. These all are special. So what is that? A reaction in which rate of reaction is independent on the concentration terms of or concentration of reactant in the reaction. So, sir, it's a special type. Can you give examples? Yes, you can take example here. This is first one. What? Enzyme catalyzed reaction. Here second example, photochemical reactions. Here you see the reactions which are taking place in the presence of metal surface. Okay, now I want to tell you one important point to you. What is that? Here you see this enzyme catalyzed reaction. In these reactions, all of you see, rate of reaction is directly proportional to the efficiency of catalyst. You have to take it like efficiency of catalyst. Here see, but it is not, rate of reaction is not depending on the concentration of reactants. Not depending on the concentration of reactant. It is depending on what? Rate of reaction is depending on what? Efficiency of the catalyst. You can take like that. Efficiency of the catalyst. Have you got it? So take it clearly. Efficiency of the catalyst. Here. Where in which reactions? In these reactions. Very important point, this one. You keep it in your mind. Next one, in this reaction, photochemical reaction if you take, in the photochemical reaction, rate of reaction is depending on what? Intensity of light. Intensity of light. You can take intensity of light. Rate of reaction is depending on intensity of light. This is also very, very important point. Have you got it? And one more thing you can take here. Rate of reaction here in this case. Okay. Depending on the surface. Metal surface. Okay. Metal surface. Is it clear? But in these three cases, rate of reaction is not at all depending on the what? Concentration of reactant. Here if you take this one, here in the first example, the rate of reaction is depending on the efficiency of the catalyst. In the second type, rate of reaction is depending on the intensity of the light. Note it down all these points one by one. In the third type if you take, here the rate of reaction is depending on the metal surface. Have you got it? Surface of the metal. Have you got it clearly? You take it first one theory part, you should have clarity on this. Is it clear? These 3 points. In these 3 types of reaction, rate of reaction is depending on different factors. Is it clear? Okay, so take it down clearly. Any doubt you can ask me. After that, one example I will give you for each type. Okay, so take it down. Right, is it clear? Right, now you can take examples for each type of reaction. Example for each type of reaction you can take it. Here you see this. You can take this one, first one. Here generally you know many enzyme catalyzed reactions are there. You can take enzyme reactions, but here I want to give you first example for what? Photochemical reaction. So photochemical reaction, H2 gas plus Cl2 gas in the presence of light. You can take here like this. Here you see this is also gas. Here you have to focus on one important point. What is that? Here the rate is not depending on the concentration of H2 and not depending on the concentration of Cl2. It is completely depending on what? Depending on light. Okay, intensity of the light. Is it clear? So take it down like this. So this is photochemical reaction example. Next one, second, you know very well, that is reactions which are taking place on the metal surface. Reactions which are taking place on metal surface. For that example, you can take here, that is 2HI. 2HI gives H2 plus I2. You can take. Okay. Now you can take like this. Here in the presence of gold surface here. Here surface. Who is providing surface here? Gold is providing surface. Everyone should focus here. Okay. One more example I want to give you for the metal surface. Here you can see this. Okay. So that is 2NH3 gas gives, what is that? Platinum you take and high pressure, then it will be converted as like N2 plus 3H2 gas. So here you can see one by one. Here these two are examples for the what? Metal surface. Example for what? Metal surface. Okay, the reactions which are taking place on the metal surface. Here the rate of reaction is depending on the metal surface which is being provided by metal. Everyone should focus. And whereas coming to the photochemical reaction, here see the rate of reaction is depending on the intensity of the light. If the intensity is high, automatically rate of the reaction also high. Have to have clarity here clearly. So these are in this all reactions, rate is not depending on the reactants concentration. Have you got it? Take it down clearly. You know very well enzyme catalyzed reactions. There are many enzyme catalyzed reactions. You can see, you can take. In that enzyme catalyzed reaction, the rate of reaction is completely depending on the what efficiency of the enzyme catalyst. Have you got it? So take it down up to here clear. Any doubt? Once you take these examples, then we will go to the next point. Okay, now coming to the next. Now I am taking one example for zero order. So graphs also we will discuss one by one. Here you see. First I am taking a reactant R gives products. Here the simple reaction I am taking here. Simple reaction. This simple reaction I am taking here. Have you got it? So first you write a rate equation. You all know very well. Rate. A rate is equal to, rate we can represent with small r. So rate is equal to R, small r is equal to, you can take K into R to the power 0. What is this? This is nothing but a rate law. You all know very well. So nothing but a rate law. Rate law or rate equation. Have you got it here? You see this? Here rate law or rate equation. We can write with the help of this one. You know very well this is a zero order reaction. So we can, that's why we can write rate law. Okay. So but you people know very well. Just you take this one, equation 1. Equation 1 you take. Okay. So now here you see, but you all know very well, rate we can express what? Minus of dr by instantaneous rate, dr by dt. Have you got it what I am saying here? You see clearly here rate is equal to minus dr by dt. This is equation 2. This is what? Equation 2. Okay, just you take. Rate means instantaneous rate. This is what? Rate law. That one I am taking it as like what? Equation 1. This is I am taking it as like equation 2. So rate means what? Smaller. So therefore you can write that is minus dr by dt is equal to k r to the power 0. What is this? This is a differential rate equation. This is called differential rate equation. All of you take it. It is a differential rate equation. Have you got it? This differential rate equation, because in the rate place, here we placed that minus dr by dt, that's it. This is called differential rate equation. But if you take differential rate equation, it is not useful in all cases to calculate rate law or rate of the or order of the reaction. It's not possible. Why? What is the reason? Here see, this is very important point. Differential rate equations or differential rate laws, if you take differential rate laws or differential rate equations, if you take here, what is there? Instantaneous rate of reaction. Instantaneous rate of reaction, here if you take instantaneous rate of reaction, we can calculate by plotting tangent. Okay, so the slope of the tangent we need to calculate. That gives what? Dr by dt value. If you substitute the slope of the tangent, you will get dr by dt value. If you substitute dr by dt value, you will get rate equation. Then only you can calculate order of the reaction. Have you got it? So that's why differential rate equations are not convenient to calculate what? Always calculate rate law or order of the reaction. So then what do we have to do here? So we need to do what? We need to integrate this one. We need to integrate. We need to get integrated rate equations. Have you got it? This is called what? Differential rate equation. In the differential rate equation, this term is there, dr by dt. Dr by dt, if you want to calculate, here you need to plot a tangent. Okay, so tangent, slope of the tangent gives dr by dt. Always if you want to calculate tangent, it's a little bit difficult. So that's why we should not use this differential equation, because this value if you want to calculate is giving some trouble and always not possible. So that's why here differential, instead of using differential equations, we are going to use integrated equations. Have you got it? We are going to use integrated equations. So this is differential equation. So now we are going to do what? Integration. I mean integrated rate equations we are going to get. So from this differential. Okay. So take it down, this one. After that, here you see. Now our concept is what? Integrated rate equation for zero order. All of you put side heading. Integrated rate equation for zero order. Integrated rate equation for zero order. If you want to get integrated rate equation for zero order, what do we have to do? So differential rate equation, I am going to what? Integrate. So here you see this minus dr by dt is equal to k into what? R to the power 0. That means you all know very well r to the power 0 is equal to 1. So therefore we are writing, okay, so this reaction we are writing, this equation we are writing dr by dt is equal to k. Okay, dr by dt is equal to what? K. Is it clear? Now here all of you see here one important point. So here you see this negative charge and dt I am taking this side. So therefore you can write dr is equal to minus k dt. Okay. So now here what do we have to do? Here both sides integrate. Okay. So this equation is there, no? Both sides take integration. So if you take both sides integration, here I am writing here integral dr is equal to minus of, you can take dt, integration. So if you do integration, this term will be converted like this. What? R is equal to here minus kt after doing integration plus I is equal to constant. So if you do integration of constant will come. That constant I am taking it as like what? I. Have you got it? So take it down. So this is equation A, you take like this. Equation A. Have you got it? Equation A you take, right. Now after that here, now I am taking t is equal to 0. T is equal to 0 means time is 0. Whenever you take time is 0, initially here R is equal to initial concentration, R naught downside. This is initial concentration. Okay, whenever you take time t is equal to 0, so concentration is what? Reactant concentration. Initial concentration is R naught. So you have to keep it in your mind like this. Whenever you take T0, so R is equal to R naught. These values I am substituting in the equation A. So substitute, okay, equation B, okay, equation B in equation what? Or simply you need not to do this much. Just you substitute these values in this equation. Automatically what you are getting? R naught is equal to T0 minus K into 0 I. Therefore you are getting R naught is equal to I. You take this one equation as a B. Have you got it? Can you see this? Okay, done. So take it like this, this is equation B. Now what we are doing is substitute. Can you see? Yeah. Substitute equation B in equation A. Substitute equation B in equation A. So now I am substituting here. You see R is equal to minus KT plus I is equal to R naught, no? So therefore you can take R naught. Is it clear? So this is integrated rate equation for zero order reaction. Everyone should focus integrated rate equation for zero order reaction. We don't have any problem here. So simply this is remaining concentration of reactants after T time. This is initial concentration and this is the rate constant. See clearly it's not, we don't have any difficulty here. So integrated equation we derive from the differential equation. Again I am going to explain here. Focus one by one. Here see, first I am taking differential rate equation. So in the differential rate equations, dr by dt, if you want to calculate, you have to what? Someone? Okay. So if I want to calculate dr by dt, so it's not at all convenient. So that's why differential rate equations we are converting into integrated rate equations. So that's why we did integrations both sides. Okay, by doing integration we got A, and by doing this one we got B. So A in equation B, substituted equation B in equation A, we got this integrated equation. Is it clear? Now here you see, after integrated equation what do we have to do, sir? So clearly I want to give you graphs, excellent for objective purpose. Very, very important. I am going to give you now those graphs. You have to have clarity. Okay. So now you must remember this formula. Right. So have you taken this one? Okay, done. So now here you can take here. Okay, done. Okay. Graphs. So now here you see, if you want to understand graphs here, now you need to remember one point. First, you know these relations, you should have clarity here. Rate is equal to what? K. We have taken this only, no? This example. So always I am following R gives products. Okay. R gives products. Don't forget about this. So I have taken anything to the power 0 is equal to 1. You know very well. So therefore what happened here? Rate is equal to K, constant. Rate is equal to constant. There is no change in the rate. Okay, rate is constant where in zero order reaction. Okay, so now here you see the graph. So now I am going to plot graph here. Here you see I am taking rate. Okay, take rate, and this side I am taking what? Concentration of reactants. Concentration of reactants. So if you take the concentration of reactants and rate graph, here you see all of you, here rate is independent on the concentration of reactants, you know. In the zero order means special types of uncommon reactions. Uncommon reaction rate is not depending on the concentration of reactants. So that's why here see the graph is coming like this. Have you got it? It's a constant. Is it clear? Take it down clearly. Very important objective purpose, right? Now coming to the next one. Next graph you can take here. Again I am going to give you here one more graph. To make you confused, they change terms, but the concept is same. Here you see, here I am taking rate, this side, y-axis. On the x-axis I am taking time. Whatever you take, time you take, concentration of reactants you take, whatever you take, what's going on here? Very simple. Very simple here. That is, rate is not changing because rate is constant. Because rate is constant. That's why here we have to take these two graphs based on this point. Based on this point. Have you got it? So clearly you can take. So rate is constant. The graph with respect to what? Reactant, concentration of reactants, rate and time graph. Here rate is constant. We get like this. Have you got it? So this is first. You can take like this. Is it clear? Any doubt in this one? Here. Note it down this one. Next, after this, here next we can take one more concept here. What is that? You see here. Now units, okay, units of K here, you know very well, units of K. So general units of K, moles, liter, whole power 1 minus n, second inverse. So now n is equal to what? Order. Here order is equal to what? Zero order. Have you got it? Order is equal to zero order. So now you substitute here. So substitute here mole. So to the power 1 means mole, liter inverse, second inverse. So these are the units of what? K. Have you got it? So for zero order reaction. You can take this one. After that we are going to focus on the next graph. You take this. Clear? Now. Okay. Now here you can see this. Okay. Now here see the next graph. You can see this. Here you know very well R is equal to minus KT plus R naught. Minus KT R naught. Now we are going to plot graph. So for this one. Okay, so you know very well y is equal to mx plus c. Y is equal to mx plus c. You take like this. Okay, so now y is equal to mx plus c. If you take y axis, you can take here y axis. So y axis is what? R. X axis time, t you take. Okay, t. Now m is equal to what slope? Which slope it is? Negative slope. Okay, so negative slope, it comes like this. Negative slope. Have you got it? So negative slope. What is this? R naught. This is R naught. So slope is equal to minus k. It's a negative slope. That's why we are getting like this. Okay. So slope, if you want to calculate, you have to take tan theta. So you can take this theta angle. You have to take that angle. Have you got it? So now here, this is the graph for what? This one. Is it clear? Any doubt in this once you check one by one? Any doubt in this? No. Okay, done. So after this, what do we have to do? Right? So take this three graphs completed. Now two more graphs are there. We will have discussion in the half-life. So in the half-life, we will get complete command. So you take these three graphs. Okay, right. Now after this, we can take the concept, next concept. Here you see, that is half-life. Half-life. What is meant by half-life? Half-life means very simple. The initial concentration, the time required to become initial concentration into its a half. That is called half-life. Half-life means, for example, you take 100 grams. If you take 100 grams, so how much time is taking to become, okay, to become 50 grams? 100 grams, if you want to make it as like a 50 grams, you have to take, that time is called as half-life. So here everyone should remember, T time. Here you see, T is equal to T half you take. T is equal to T half. R is equal to remaining concentration of reactants. R is equal to remaining concentration of reactants. Okay, that is R naught by 2. Initial concentration becomes half. So these two terms we are going to substitute in this formula. Which formula? That is integrated rate equation for the zero order. That is R is equal to minus KT plus R naught. Okay, so integrated rate equation for zero order. In this, what we are going to substitute here? Half-life. What is half-life? The time required to become initial concentration into its half. That time we can call it as like a T half. T is equal to, in the T place you can take T half, and remaining concentration of reactants become its half. That therefore R naught by 2 we can take here. So therefore R naught by 2 is equal to minus KT half plus R naught. Okay, so now what we are going to do is, just you see this calculation, simple calculation. So KT half is equal to, here you see, it goes that side. So therefore R naught minus R naught by 2. So therefore you can take T half is equal to KT half is equal to, if you subtract this one, it will become 2R naught minus R naught by 2. So therefore finally you will get R naught by 2. So therefore finally you can write T half is equal to R naught by 2K. R naught by 2K. Here this is the what? Half-life for the zero order reaction. Half-life for what? Zero order reaction. Everyone should focus here. T half is equal to R naught by 2K. Okay, this is half-life for whom? Zero order reaction half-life. Here everyone should remember, what is that? T half is depending on the initial concentration. That means T half is directly proportional to the initial concentration. Half-life is depending. Don't forget about this. Here see, time is depending on the initial concentration of reactants. So take it down, this is half-life. Now you can take graph for this. Here see, I am taking time, you can take reactants, you can take, okay, concentration of reactants. You can take concentration of reactants, and you can take T half. No, oh, okay, T half. Okay, you can take T half. So now here you see, you can take like this. Can you see this? Little bit upside I'll write. Here T half is equal to R naught by 2K plus 0, you take like that. So for your clarity, here I will write upside in detailed manner. So you can take here. So I am going to plot a graph for this. That is, you can take T half is equal to R naught by 2K plus 0, you take. So this is nothing but a y is equal to mx plus c. C is equal to what? 0. Here x is equal to what? R naught. M is equal to slope. Slope is equal to 1 by 2k. So now you plot a graph for this. So now you plot a graph for this. If you plot graph like this, can you see this? Okay. So now here you see this y-axis T half you can take T half, x-axis R naught you can take. So now here see, this graph comes like this. Have you got it? Here slope is equal to minus 2k, not minus 2k, 1 by 2k, 1 by 2k. Okay, so this is theta value. Have you got it? So you can take like this. Okay, so this is a graph. This is fourth graph, very important. You should have clarity. So we are taking half-life. For the half-life, we have taken like this, y is equal to mx plus c. So we have taken like this. This is half-life for the zero order. Have you got it? Half-life for the zero order, very important. Everyone should take here one by one in detailed manner. You take this. Next, after this, we'll go for the next one. That is, this is half-life. So completion. So after this, we can take, you can take next one. That next one, now you can take next one. So what is the next one? For completion, for half-life of the reaction we have discussed. Now we need to discuss about for the completion of reaction. So completion of reaction. Completion of reaction purpose, what can we take? So simple, we can take like this. Here T half, you know, T half-life means you can write like this, T50. You can take T50. T50% is equal to what? R naught by 2K, you all know very well. Okay, but now what we are asking? Completion of reaction. Completion of reaction means what? 100%. So 100%. Just imagine like that. 100% is not possible. Okay, whatever it is. So 100%. You can take like that. 100% completion. Now 100% means T 100% is equal to, you can take 2 into T half, no, 2 into 50% you can take. That is equal to 2 into R naught by 2K you can take. R naught by 2K you can take. This one get cancelled. Okay, so now what is the answer for this T 100%? T 100% is equal to R naught by K. T 100% is equal to R naught by K. Okay, so take it down this one. Okay, very important. Okay, right. You take it like this one, right? Okay. Now coming to the next point. This is very, very important for solving questions purpose. So you take this one. After this, we'll come to the next mode. Okay, right, done. So now here you take here, that is next one. What I am going to take is very simple. You take a chemical reaction. Okay, you take a chemical reaction. Here you are taking that chemical reaction, R gives product. Okay, so R gives products. You take this one. Time, here see, very important, time 0, that means initial state. You are at initial state. That means, what is that? Time t is equal to 0. Here, concentration of reactants, initial concentration R naught. Products initially 0. Time t, after t time, time t. So what's going on here? Initial concentration X% decreased or X decreased, okay, and X increased here. Here decreased means here increased. Have you got it? What I am saying? Okay, initial concentration means this one. Okay, after T time concentration means this one. Have you got it? Now here these values we are going to substitute in our integrated rate equation of zero order. It's a zero order reaction. In the zero order reaction, initially concentration of reactant is R naught. Okay, concentration of reactant is R naught. You can take R naught. Can you see it? Okay, so now, and products concentration 0 because initially there are no products. So now what is going on here? We can take like this. T time. After T time, initial concentration X decreased. The decreased quantity produced products. Have you got it? Like a products. Is it clear? Now substitute in the integrated equation. R is equal to minus KT plus R naught. You can take like this. R is equal to minus KT plus R naught. Okay. So now here you may get one doubt. Here you see one by one. Here this equation we can write like how? We can write like this. R naught minus R by, what can we take here? T is equal to K. Okay, so overall directly I wrote here, you see all of you, directly I wrote here, integrated equation I have taken. In the integrated equation, here just I changed it like this and we can write like this. Now everyone should focus. From the integrated equation we have taken this one and this part is equal to R. Don't forget. R means what? Concentration of reactants after T time. Have you got it? Concentration of reactants after T time. So now substitute in this. K is equal to R naught minus, what is this? R naught minus X. It will become plus divided by T. That means X get R naught get cancelled. Okay. So here X by T. So that what is X here? Everyone should focus. What is X here? X is equal to products formed. Don't forget, it's initial concentration. Initial concentration means R naught. Generally in our equation we are taking R. What is R? R means remaining concentration after T time. Remaining reactant concentration after T time is R naught minus X. Okay, so here see, in the integrated rate equation, I am substituting here that I changed this one like this. I here then R naught minus R by T. R is equal to what? R is equal to, you know, R naught minus X. I am substituting that point here. You see, R naught minus R naught plus X. So because if you substitute, minus into minus will become plus. So overall you got what? K is equal to, finally can you see this? Okay. K is equal to what? X by T. Therefore we can write like this, no? What? T is equal to X by K. You can take like this. Okay. So now one more graph is there. Very important. One more graph is there. What is that graph? That graph is, here you see, the graph between time and concentration of products. Okay, so first of all of you take this one, all of you take this one. Is it clear? So take it down, this one. Next, here after this we will focus on the next points. Okay, right. Now here see graph, I am going to take the graph. So what is that? Here you can write T is equal to x by k. You can take T is equal to time x by k plus 0 you can take, no problem. Okay, plus 0 you take. Y is equal to mx plus c. Okay, y is equal to mx plus c. On the y-axis time you take, on the x-axis what the concentration of products. Okay, x is equal to concentration of products, concentration of products. Okay, so now here you see this m is equal to k, m is equal to 1 by k. So now you take the graph. Okay, so this is y-axis, y-axis I am taking time. Okay, now on the x-axis, I am taking concentration of products. Okay, concentration of products. Okay, so 0. Now the graph is coming like this. Have you got it? So this is slope. Slope is equal to 1 by k. So you can take tan theta. Have you got it? So now this is total graphs. Total 5 graphs are there. We have discussed completely about 5 graphs. Okay, so is it clear? Any doubt in this? One by one you can see all in detailed manner we have discussed about this zero order integrated equations, graph, and we will solve some problems, but we don't have time to discuss all those problems. And one more condition is there, I will complete that condition, and tomorrow we solve some problems on the zero order reaction, and next we'll go to the first order integrated equations and about first order reactions. Okay, so after this, here you see very important point I'm going to tell you. All of you, everyone should have clarity on this. Up to here I have taken example, this one, R gives products. Okay, R gives products. Okay, everyone knows we have taken this. For this integrated rate equation is what? What is the integrated rate equation for this? R is equal to minus KT plus R naught. Okay, this is integrated equation, rate equation. And next one, T half is equal to, what is that? R naught by 2K. Have you got it? Now you take one more thing, T 100% completion, lifetime. Okay, half time, lifetime. Okay, this is half time, this is lifetime. So for this you can take R naught by K. Okay, so these three these three equations which we have taken here, these three equations is applicable for this. According to our syllabus, mostly they will give zero order means reactant 1. Coefficient is what here? 1. Don't forget about this. Here reactant coefficient is 1. Okay, gives products. Okay, we don't have any problem in that. But sometimes they may give like this also. What is that? Here 2R gives products. It's a zero order reaction. They'll mention like this. For zero order reaction, 2R they mention. 2R if they mention here, this rate equation will be changed. Here see, R is equal to minus, this 2 is there, no? That with this 2 you have to multiply with the K. Okay, so therefore minus of what? 2K should be taken, 2KT plus R naught. If you get reaction coefficient 1, this is okay, this is okay, this is okay, we don't have any problem. But whenever you get here 2r, this equation will be changed like this. Have you got it? Same story here also. What? T half is equal to r naught by 2 into 2k, because we have to take 2k, no? 2 into k, 2k we have to take here. Same thing here also, 2k into 2, 4k. Okay, so now here you see t lifetime 100% is equal to what? R naught by 2k, R naught by 2k. This is for what? This is for these expressions. This expression, if the zero order reaction is given like this, you have to take these expressions. For example, now you see one more point. For example, in case 3 they gave, you take here 3r. These formulas are not possible. We should not use these formulas. What do we have to do, sir, then? So very simple. With that 3 you have to multiply this k. 3kt minus 3kt plus r. And here 3k into 2. What will come? 3k into 2 will become 6k. Okay. So here why I am changing all this thing? Here coefficient. Okay.